Okay, I think all of the participants is now in this room. So before I will start, can you hear me clearly, everybody?
Yeah.
Yes.
Yeah.
Okay.
Yes.
Okay, now. Okay, I will start this webinar. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, good afternoon, ladies and gentlemen. We are delighted to welcome you for international webinar that organized by the Food Science Study Program or Formasip IPB University in collaboration with the Department of Food Science and Technology, IPB University, by the theme Texture Analysis Principles. My name is Nurafi Razna Suhaima. It is an awesome and precious chance for me to become a master of ceremony in this event on Thursday, 29th July 2021. And now, please let me welcome our speaker and participants. Welcome to our main speaker, Honorable Mr. Paul Brown, International Sales Manager, Stable Microsystem from United Kingdom. Good morning, Mr. Paul.
Morning, good afternoon, everyone.
Yes, good afternoon here. And also welcome to the head of the Department of Food Science and Technology, IPB University, Dr. Eko Haripurnomo, S.Pi. Good afternoon, Dr. Eko.
Very good afternoon.
Good afternoon also to the Honorable Olaf Lecturer of Department of Food Science and Technology, IPB University. And the last but not least, welcome to all participants of this event. Our highest appreciation and thank you very much for your participation today. Ladies and gentlemen, here is the agenda for today's webinar. We will open with opening session and following by welcoming remarks. And we also have group photography before our main event, which are presentations and questions and answer session. And we also have door prize for 3 best questions today. And we will close with closing session. First of all, before we start our agenda today, let us pray together to God according to our beliefs. Pray, begin. Finished. Well, ladies and gentlemen, we need to inform you that the link of the attendance of this webinar will be accessed in the end of this event. So please join this webinar until the end to get the certificate. Ladies and gentlemen, let's start this event, which is our first agenda today, is welcoming speech that will be delivered by the head of Department Food Science and Technology, IPB University. I would like to invite Honorable Dr. Eko Haripurnomo, S.Pi. To Dr. Eko, please, time is yours.
Very good afternoon, and thank you for allowing me to have opening remark in this webinar entitled Texture Analysis Principles. And I think first I have to welcome and thanks to the speaker today. So welcome and thanks Mr. Paul Brown from Stable Microsystem as an international sales manager. And also I would like to thanks to Professor Purwiyatno, who will be the moderator for this webinar. And of course, also thanks and congratulations to Formasip for hosting and organizing this webinar. I think it's very timely as well as a very important moment and very important event for us to have this webinar on texture analysis principles, because I think every one of us understand that texture analysis is indeed one of the important parameters that we need to analyze, that we need to monitor during the production or the assessment of product quality, especially food product quality. And I think for almost every one of us, we are familiar with texture analysis, and I think it's a very good time also to even learn further the texture analysis principle from the prominent expert that we have today. So thank you again to our speaker and moderator. Yeah, and I think this in this event, I also invited one of our industry partner, which is Palscard, Asia Pacific PT Ltd, as the emulsifier manufacturer, and I think it is also an important event for not only for students to learn from the industry, but I think it's also good for the industry to share the current development in their technology, to make sure that the technology developed by let's say by machine manufacturers is fully utilized by researcher, by students, because I think we also need to inform that the students joining this seminar are mostly graduate students, so they are the future researcher that will, of course, hopefully, many of them working in the area of texture and rheology analysis. And for me, myself, texture analysis is not something new, because I remember I did my master and my research was on the analysis of food texture using one of stable microsystem instruments. So it is a very useful and powerful tool and equipment that we can use to indeed characterize the physical properties of food product. And I think there are new current developments that we need to learn from the expert. So I would also like to thank to Pak Henki, our old friend. We know him since, I don't know, probably late 90s, when we purchased our first texture analyzer from him. And that equipment is still in use till today. So that means that this equipment is indeed reliable, and we can use it for a long time, of course. Yeah, and with that, I would probably expect that this webinar will be useful for everyone, and make sure that you enjoy the webinar and take the most from the webinar. Thank you and great success. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the speech, Dr. Eko. Okay, now, before we start our main event today, let us take a group photography first. And we have 7 slides here. So to all participants, make sure you turn on your cameras, because we will take the photo and I will count. And for the committee, can take a photo and help me. Okay, for the first slide, please be ready, everybody. I will count on 3, 2, 1. Okay, for the next slide, which is the second slide, we will take a photo on 3, 2, 1. And then the third slide on 3, 2, 1. And the fourth slide on 3, 2, 1. And then the next slide, 3, 2, 1. And the sixth on 3, 2, 1. And finally, this is the final slide, or the last slide. Okay, I will count on 3, 2, 1. Okay, thank you very much for your time and also for your smiles. And now we will start our main session of this international webinar. It will be handled by our moderator here, Professor Dr. Purwiyatno Hariyadi. He is a lecturer of the Department of Food Science and Technology, Faculty of Agricultural Technology, IPB University. Moreover, he is also a Vice President of CADEX. Without further ado, I would like to invite Professor Dr. Purwiyatno Hariyadi. Please, time is yours.
Okay, thank you very much. Let me camera on. Okay. Can you hear me?
Yes, we can hear.
Yes, clear, sir.
Thank you. Thank you. Today, Pak Hengki, can you see my?
Yeah. Thank you, thank you.
My special gift from Pak Hengki. That's why I didn't turn my video on before to give you some surprise.
Terima kasih, Pak.
And regarding the door prize, I think you also will have a very nice, what do you call it, a polo shirt for the one that have a lucky. Oh, very much the same. Yes. Okay, without further ado, we will start this session. This is about texture analysis principle. As we know, texture is a very complex characteristic of food. People have their perception about texture and very much sensitive in principle, but also personal. And as we know, the perception of texture for individual is also depend on many things, depend on their experience and also and many other characteristics of the food when the food is being chewed, being eaten. If we will try to characterize the textural properties of food using an instrument, and how are we going to do it? And what kind of feature that we can take as an information from the instrument itself. So we are very lucky today. We have experienced expert in this field, especially in the area of texture analysis, which is Mr. Paul Brown. So welcome to our Zoom seminar, Paul. And also thanks for Pak Hengki for arranging this event with the Formasip. Okay, Formasip is a student association of food science from IPB. Okay, well, so without further ado, I would like to invite Mr. Paul Brown. I know that from the information that I got, he is very knowledgeable and experienced in the field. He has been working with stable microsystems since 2014, if I'm not mistaken. So long history in the field of textile. So with that, please, the time and the screen is yours, Paul.
Thank you very much, and thank you everybody for attending. As already said, my name is Paul Brown. I'm the International Sales Manager for Stable Microsystems here in the UK, and I look after the region of Indonesia with our esteemed distributor, Rabina, Mr. Hengki. So what I'd like to do this morning is I have a presentation to show you, which covers the 7 principles of texture analysis that we work from as Stable Microsystems, which hopefully gives you a very good overview of the potentials that are available with regards to testing and analysis from the texture analyzer. So if I share my screen, I'm hoping that everybody will be able to see this. Let's just run the presentation. So I'm hoping everybody can see my presentation. It should be a slide, an introduction to texture analysis.
Yes.
Excellent. So first of all, Stable Microsystems have 7 instruments, which all of the principles that we talk about today are available throughout the range of the instruments, and we can discuss the various models that are available a little bit later. This is just the first slide. So we're going to very quickly overview the company introduction, why texture analysis, how we can measure texture, a machine versus person, and then we'll look at the 7 principles that we work through with the texture analyzer. So Stable Microsystems have been manufacturing texture analysis since 1983. Was the very first instrument was manufactured by ourselves. All the design and manufacturing is located here in the UK in a little village called Godalming. And it's all in-house. So we design everything, all the fixtures, all the software, all the instruments are designed in-house. We don't externally design, although we do have collaborations with various companies and academic institutes around the world where we work to build and design fixtures and probes to help with the varying types of products that the texture analyzer is looking at. Leading innovators, we have been since, well, for more than 30 years. And we sell in over 60 countries. In fact, we sell globally, all from here, from the UK, from Godalming, and we work through distribution in the main, including our distributor, obviously, in Indonesia, which is Robina and Hengi, who you have already been introduced to. So why measure texture? Whether it's research and development, whether it's academia, or whether it's quality control, it gives you a quantifiable data about the product and about potential changes that are happening in the products. So in research and development, that could be a new product development. It could be a change in formulation. It could be a change of ingredient. In food in particular, things like removal of glutens or removal of sugars or salts is quite a substantial area that we work in, or that the instrument works in. And currently a very popular area of development is meat replacements. So soya or pea proteins as a meat replacement is a very big area in the research and development. Obviously, there is potential for quality control as well, to making sure that there is minimum batch variation, or whether it be for storage, for shelf life. Of course, environmental influences change as well, but the supply variations. So if you're changing suppliers for ingredients, again, this can change the product, the final stages of the product, and hopefully our instrument can help quantify those as well. If you haven't already used the texture analyzer, it's a very visual product. So once the test is once the instrument has made its test, it creates a graph, which then enables you to very visually see what the product has done through the graph, but also then after analysis, there is a whole series of numerical data points that are possible to review as well. And we'll see some of those as we go through the slideshow today. How do we measure texture? I mentioned earlier a little bit about 7 principles, and these are the 7 principles we work to. And these 7 principles in the main cover a very large percentage, 95, 97% of the tests that we create in or on the texture analyzer come under one of these headings: compression, puncture or penetration, tension and extension, shearing or cutting, adhesion, extrusion, and bending and flexing. And we will today take a look at every one of those and some of the type of applications that are possible with that, with those individual principles. Machine versus person. Why is the machine better than the person? The very best texture analyzer available is yourself, is the human person, whether it be with our eyes, our nose, our fingers. We can quantify, or we can test products very easily with our hands and our mouths, etc. However, to quantify those, the variability between person to person is enormous and it's infinitely variable. The advantage of the texture analyzer and the stable microsystems texture analyzer is that it doesn't have a bad day. It doesn't not sleep. It doesn't have a really horrible journey to work in the morning, so you're not in a very good mood because you spent 2.5 hours in a car stuck in traffic jams. The instrument just records the data that we give it effectively. So we tell the instrument to do something, to move up and down at particular speeds, and it records that data for us. So it's very objective and very repeatable. And that is the benefit of the instrument over the person. The challenge is that we are multi-module sensory for the human, where the machine can be one-dimensional or two-dimensional in certain areas. But that does still have its advantages, and certainly the instrument will be objective and repeatable in its measurements. So our texture analyzer, this is our standard instrument. This is called a TAXT Plus. You would have seen earlier that we have 7 instruments in our range. Of the 7 instruments, this instrument is the most popular and is the most common. We have more than 10,000 units globally in industry and academia, be that in research and development, be that in quality control or academia, and whether it be in food, ingredients, pharmaceuticals, cosmetics and personal care, materials science. They are used in a whole range of industrial and academic areas. So basically, that is the instrument. It has a base, it has some manual controls. You can see the arm, which then moves up and down. We can work in both directions, so we can work in a compression basis, so the arm moves down and up, and the arm can move up and then back down if we wish to. And our instrument uniquely can also make multiple passes in a cycle potential, and we can do holding times, holding forces. So there's a large variation of tests possible. We'll see some of those today, but if you have any questions, or if there are particular tests that you want to discuss, that's potentially possible in the Q&A or afterwards with our dealer principal. There is the slide again for the 7 principles. So we will now go through each one of those individually and try and give you some examples of each of the principles. Compression. What is compression? So compression, it's a very basic physics. As long as the diameter of the probe is equal to or greater than the surface of the sample, then you should receive compression of the product. Whether that be packaging, or whether it be a cake or a sweet or a biscuit or an ingredient, we can make compression of the product. We're going to squash it. We're going to understand how firm it is, what the resistance to deform that product is. So here is a very easy and quick example. So the probe comes down, touches the top of the sample fails, and the probe returns to the start. This is a simple graph, and you're going to see this throughout the presentations. We have a force time graph, XY axis. As the probe comes down and makes contact with the sample, we have a live graph, which will inevitably start to increase in force up to the point of rupture or failure of the product, in which case the force reduces because the product has failed and there is no more force, and returns to the start. Once we have this graph, we can make analysis of the graph. We can look at maximum force levels, we can look at area under curves, we can look at gradients of lines, we can look at positive, we can look at negative areas. So we have a wide range of analysis once we have that graph. But this is very simple. The probe is moving down, making contact with the sample, and then returning once it's created or made the test that we wish it to do so. Just some more examples here. Just all compression examples. So squashing of the sweet, of the teddy bear, of the gel-based sweet, whether it's a tablet or whether it's a sponge or whether it's a cup. These are all compressions. One thing to remember here, and also with penetration, is that quite often once we have created a compression test, we are unable to retest that product because we actually take the test and we compress or we change the structural properties of those items. So once we've made that test, it's not possible to retest that same sample. But just some examples of how compression works. Something I'm sure you will be aware of is a TPA test, or texture profile analysis. This was originally designed back in the 1960s by a very renowned texture analysis expert, Mr. Bourne, and it was designed to look at the twin bite or two cycle of a texture of a product, so a compression. Hopefully, if I can make this run. So the compression probe comes down, creates an initial graph, returns, holds for a period of time, and then makes a second pass to create a second test, thus the 2-bite cycle. Now, although TPA works very well for certain products, it has been changed over the years by a whole number of people. And although it does work well with some products, it doesn't work with all products. And I would suggest to you that you have to be very careful if you're going to use the TPA to make sure you understand exactly what you're going to get from that test. Let's see if we get to the next slide. So here is a general review of the TPA just very quickly. So you're looking at things like fractability, the hardness, the stringiness of products, the adhesiveness of products. And to try and give you an example is, for example, chocolate. Generally a hard chocolate doesn't have a second bite. It doesn't have stringiness. It doesn't generally have an adhesiveness potentially. It certainly will have a hardness and it will have a fractability. So if you're using this type of calculation, it may be that the second pass doesn't have the calculations that are possible. And just to point out, we add 3 additional potential areas that you can analyze with TPA. We look at cohesiveness, we also look at gumminess and chewiness of the product. Additional compression type tests are, we call them bulk testing. So if a product is multiple particulates or irregular in shape, non-homogeneous, rather than testing individual small samples, you can test them as a multiple sample altogether. And this gives you a more repeatable test than doing them individually. And we call this bulk testing. Again, you can see on the graph here, it's a forced time graph, but instead of just a single line going up, we have multiple peaks, which can represent the fractability of the different products. And the video that you're seeing is cornflakes, the breakfast cereal. Individually, they're very irregular in shape, so testing them in bulk has a much better repeatable test. Puncture and penetration. Again, the basic physics is that the probe is smaller than the surface area of the sample. We would normally, for puncture and penetration, recommend that the probe be smaller than probably 10 millimeters. Potentially it can be if it's larger, if it's a very big sample, but between 2 and 10 millimeters, cylindrical probes is what we would certainly recommend. And within puncture penetration, as well as cylindrical probes, we have things like cones, ball probes, needle probes, multiple needle probes, etc. as well, depending on the type of product you're looking for. But puncture penetration is a very useful test throughout a whole series, particularly in food products, but also gels and semi-solid products as well. So again, a very simple test looking, we're showing you here a lipstick or a lipsil. Hopefully this gives you a very good example of the type of test. So the graph here, again, as you can see, it's force time. What we see is an increase in force as the probe enters into the sample. It's quite homogeneous through the middle. It's quite even through the middle. So as it passes through the most force required to penetrate the product, as it continues into the product, you can see we sort of flat line as it moves through the product. But then as we return, you can now start to see that actually we can look at multiple areas of the graph and multiple areas of the product by now looking not just at the force to make penetration, but also looking at the force to remove from the product. So as the probe returns to the start of the test, it can also look at areas, for example, like the stickiness, the negative area of the curve as well. So one graph means that you can actually look at, or potentially look at, a number of areas within that graph and analysis. As I said earlier, puncture, penetration, and compression can cause irreversible changes to the product. So often a product can only be tested once. And in puncture and penetration, both compressive and shear forces can be involved or are involved. As demonstrated here with the gel test, it's the compression test. And then as the product fails, we're now into a shearing test because the product is now pushing, the probe, sorry, is now pushing all the way into the product and shearing the product. As well as cylindrical probes, we have ball probes where a surface is not flat or uneven. A good example is the muffin, but also it could be a fish-based product or meat-based product, or the meat replacement products or confectionery. Then we can potentially use a ball probe to ensure that the contact area is always the same. And where products are very hard, often penetration is the only type of test that's possible. So an example here is a bar of soap. I'm trying to think of an example on food-based products, maybe a hard candy. You wouldn't be able to make a compression of this type of product because the force required to compress would be enormous. So a penetration, for example, here using a needle probe, is potentially the only test available when testing very hard products. But you're getting an idea that there are lots of different probes, lots of different fixtures available. Penetration is suitable for products that are self-supporting, so it's not for non-self-supporting products. So, or it is if you can contain them. So you have to, if you're going to make penetration on like a cream or a fluid-based product or something that flows quite easily, then it has to be housed in its own vessel or a regular sized vessel that can be repeated each time. One advantage of puncture and penetration is that actually, again, you can look at multiple areas of the graph, but also multiple areas of a product. I like to use, we've got a couple of examples here of a pie and some confectionery with multiple layers, but an apple I think is very good. And this graph shows you, I think, a very good representation of an apple. So as the puncture penetration increases in force, this we would call the skin. So this is the outer layer of the product. So this is the force required to penetrate the skin of an apple, and then it reduces in force and we get a sort of more of a flat line through the center of the apple. So we could call that the flesh part. So we can look at multiple areas. Again, we can look at the skin puncture force requirement, but also looking at how even the flesh of the apple is as well. And again, we've got a negative area here, so potentially we could be looking at how sticky or how cohesive that apple is when it's trying to remove the probe from the apple, how much is that apple trying to hold on to onto the probe on the way out. So again, multiple areas within one single graph, within one single test, we can look at lots of different area or points within the product to understand what the product is doing or how it's changing. Like in the compression where we did bulk testing, we can do bulk testing similarly in penetration by using multiple penetration points. So whether it be multiple peas or lettuces or something that's very famous and used quite widely is the multiple chip rig. So this rig, this one here, is looking at multiple French fries. French fries are not homogeneous. They're very irregular in shape and sizes. So if you test one fry and you test another fry, there could be a very different result. So testing them in a bulk gives you a more repeatable test capability by using multiple punctures on multiple products simultaneously. So our third principle is cutting and shearing. Now, we always think of cutting and shearing as a blade. We do it every day with our knives and forks at home, but ultimately the human is the perfect cutting or shearing because we bite every day our food, be it a snack or be it a confectionery product or be it our lunch or tea in the evening. So again, many different types of blade capabilities with the texture analyzer, from things like wedges for cheese, multiple shears, and single blades as well. So we'll look at a range of different blades. A standard blade set, as displayed here, is a single blade series using lots of different areas of product. We have chisel blades, we have flat blades, we have the Warner-Bratzler blade. Warner-Bratzler is a very well-known testing, which is a V-shaped for very cylindrical type products. So things like sausages, chicken sausages, meat replacement sausages, but anything that's circular, confectionery or snack-based products. Additionally, with the flat blades, you can test virtually anything with a flat blade, any type of food-based product. And as well as being available to slice to a point within the product or to the base, we also have a slotted guide, so we can shear all the way through. So this has a slot all the way through, enabling us to go directly all the way through the product as well. So we can look at the firmness, the shear capability of the product, all within one test. Depending on the type of product, depends on the type of blade, and you can see here there are lots of different blades. If you're looking at something that is very hard or very soft, then we would recommend a very sharp blade, so what we call a craft blade. And we do a number of different craft blades. We do a small craft blade or an extended craft blade. The advantage here is that with these very sharp blades, razor sharp blades, is that you know you're going to get the same repeatable result. They're very inexpensive to replace as well. If you're going to try and do this with a very hard product or a very soft product, very hard means that you'd have to use a lot of force with the standard blade. And if it's very soft, you're not going to shear the product, you're more likely to just compress the product on an axis. So using a very sharp blade is in a better position. Blades have been developed for very specific tests. There's a very specific test called a Moore's blade, which is testing for chicken particularly, and there's a very specific test, very standard test for testing chicken and the fibers that are the direction of the fibers with the test as well. So within blades, there are lots of different variables. As well as metal blades, we offer Perspex blades. The advantage of the Perspex blade is that it's relatively inexpensive again, and also it's very quick to change. So if you're looking at soft products, so things like noodles, cooked vegetables or cooked fruits is often used. And as stated here, the AACC standard method for spaghetti firmness uses a Perspex blade. whether that's a flat blade or a chisel blade, it's all possible with Perspex type blades. Again, you can see there isn't just one type of blade or one type of test. There can be a whole series of different types of tests available. Already mentioned the Warner-Brasler blade. It's a standard type of blade. You can see here using the slot. So the blade goes all the way through the product, generally used for circular type products or extruded circular type products. There is also a square blade for square sausage testing as well, in a standard size of sample preparation. Not so much a blade, but comes under the shearing capability is a wire. This is commonly used for cheeses or butter type cutting, where something is relatively soft to be able to shear. You can use a wire. The wire is a certain tension. You create a certain tension so that, again, the test is repeatable, and being a wire, it's very easy to replace and very cost effective. Now, whether that's a bread type testing, this is a shear test that was created to do individual bread slices, or whether it's a butter or a cheese type based product, it's another alternative to a blade. As we talked about earlier, bulk testing, we can bulk test multiple tests in shear as well. The very well-known shear is the Kramer shear cell. We offer a 10 and a 5 blade. The 5 blade is shown here. Again, where product is irregular in shape or size, you would want to try and test in a multiple blade shear or a multiple bulk testing. Often this one is used obviously for meat-based products, particularly in beef, because the muscle structure is irregular. If we use a single shear or a single penetration, we could miss all of the fats or the muscle-based product and just into the nice meat area, into the standard area. And if we do that, we get one result. But then if the next shear we do is through some muscle points or some fat points, we could get completely different result. So doing a multiple shear gives us that capability of looking at multiple areas and having more repeatable result. Something that we have developed lately, a new product, is what we call a triple ring cutting system. This was developed to shear noodles, particularly instant noodles in pots. This was designed with the help of a manufacturer that manufactures noodles, so that it could work in the pot. However, we've found that actually it works really well in other areas, popcorn, spaghetti, and other food-based products where there are multiple particulates where you want to shear simultaneously. Extrusion, the consistency or the flow of product. So you can see now we're moving away from that pretty much standard test of shearing, compressions or penetrations, and looking at more unique types of testing with the texture analyzer and how a product can flow. Now this could be within development, or it could be the packaging also, and how a product, not just the textural properties, but how it performs from its vessel for delivery purposes. The most common of our flow tests is what we call a back extrusion. This is where a piston is used to penetrate into the product. The piston is approximately 5 millimeter thick, and what happens is once it's into the product can flow over the top, as you can see here with the treacle. And as the piston comes back out, we can look at how the product flows off of the piston and look at the performance detail of that product. So the piston is forced into the sample, product extrudes around the disc, and then it's measured on the way out as well as the way in. So it can measure consistency, the work of extrusion, the cohesion, and also the extensibility of the product as well. This is a typical type of graph that we'd expect to see. Again, nothing new here for you to see in that it's a force time graph. What we're seeing is the piston into the product and pushing further into the product, then coming out of the product and looking at how the product flows once the piston has become or is removed from the product. How is the product flowing afterwards? So it's good for viscous liquids and sauces, pastes and gels, fruit-based products like jams, yogurts, creams, etc. This is a really good test that can work with those products. And one of the big advantages with this type of back extrusion test is that the product can be actually tested in its original vessel. It doesn't have to be moved from one vessel to another, which potentially can create some changes in the product. It can actually sort of be in its original vessel, and you can test in its original vessel. As well as back extrusion, we can do forward extrusion, which is where we are forcing the liquid through a hole or an orifice in the base of the product here. The orifice can be changed in physical dimensions, and looking at how those products flow. So if you're looking to develop something through a squeezy tube, rather than putting it straight into the tube, we can look at how the product flows and look at the numerical data and the graphical data of how that product is suited to an extrusion or to an orifice-based vessel delivery. Bending and flexing, looking at the fracture and the break strength of products. Normally these sort of products with bending and flexing is that the product will fail very, very quickly. So whether it's potato chips or fried product that then has a hard exterior, pastas, biscuits or savory type products normally have bending and flexing properties. The standard test is what we call a 3-point bend test. I'm afraid this video is rather slow, but you'll see it in a second. So with the chocolate bar, we would expect a chocolate bar to be very fracturable or very crisp in that it fails very quickly. And again, we can see our graph here. It's slightly different. We're still looking at force, but this time instead of time, we're looking at distance. So the force is applied with a very quick increase in force and then a very quick decrease in force as the product fails very quickly. And again, one graph, but we can look at multiple areas. So although we're looking at exactly the same point on the graph, the texture analyzer can look at different data at the same point. So here we would look at hardness, which would be the force reading. So approximately 1100 grams, but at the same point of that hardness, we can look at the fracturability. And the fracturability would be the distance. So how quickly does that product fail? If the product fails in a longer distance, then it has some sort of elasticity or some sort of bend to the product. Where if it fails very quickly, it fractures and fails virtually immediately. There are lots of different types of that bending and flexing, or comes under those bending and flexing. So potato chips, fried snack goods of varying types. I'm sure you have in India lots of different types of fried snacks, crisps, Pringles, Lay's type fried products, but also dried products as well. So things like dried pastas, dried breads, etc., may have bending or flexing or failure points within their product series. Very quickly moving on to tension and extension. So where we've looked at something that breaks very quickly, tension and extension, we generally find has a more elastic property and actually has a much greater elongation capability. Again, whether that be a sweet-based product, whether it be the pre-baked, so doughs type products, or whether it be something that is solid initially, but when heated, it becomes elastic, like mozzarella cheese or pastas, etc. It's all possible to look at the stretch or the elongation of the product, either to failure or just to see how far it will stretch within the product series itself. So there are lots of different types of tensile style grips or different types of grips available to look at the elongation. We have here very specifically, this is a pizza tensile grip. So looking at the mozzarella cheese, we have roller grips, self-tightening. We have specialist grips for like a pasta or something that that you can't grip. So from experience, that if you grip something that's very soft, like a piece of pasta, what happens is when you grip it, you create a stress point at the grip point. So we couldn't put a piece of pasta in here in the bottom grips here, the self-tightening grips, because the pasta would fail at the grip point. So we create these, we call them bollard grips, to enable us to test and actually test in the central area of the product. And not just food-based products, but packaging. So we can look at the peel of product that comes under the tension and tensile grips, how much, you'll see this in adhesion as well, because this sort of falls into two categories, adhesion as well as tensile strength. But looking at packaging and the seal strength of packaging, etc., can come under both areas, and you'll see that a little bit later as well. Again, lots of different examples here of different types of tension, be it things like melted cheese. Again, we said earlier that we can test the cheese in its solid state, but if it changes under certain heats, do we want to look at that product under the certain heats as well? And that's possible with things like mozzarella cheese. We do have one very odd test, which, although it's in tension and extension, is actually in a compression method, and it's for flatbreads where we push through the flatbreads using a ball probe. It's giving us a bidirectional tensile test. And a very specific test, things like the Kiefer dough extensibility rig. So looking at the extensibility of doughs, using the Kiefer rig, again developed to look at very specifically doughs and very quick way of looking at dough. I have a video a little bit later on of this example, but looking at very different ways of products. This is again a tension type, but this is looking at packaging. So looking at the seal strength or the tension to remove a Coke can or a fizzy drink type can, but also vessels for delivering food-based products. But there's a better video a little bit later for you. And as I mentioned, adhesion, we're getting very close to the end now for you. So adhesion, looking at the characteristics of a product that's adhesive or holds things together. So whether that's deliverable pots like yogurt pots, etc., the seal strength of the pot, or whether it's the adhesion of baked goods, so the pre-baked, so doughs and how sticky doughs can be, or whether it be self-adhesive. So a very good example would be a sticking plaster that you would put on your skin. This is a really good example. I know potentially it's not in your area of requirement, but think of a sticking plaster. If you put it on your skin and it just fell off, that's not adhesive. But also you want to make sure that that adhesion is not so hard that you can never get it off. And that's really where we would look within adhesion. Just to give you an example of an adhesion, the probe comes down and makes a bond with the product. This is actually a toothpaste, but it could be a cream, it could be a sauce or some shape or form that you're looking at. How adhesive is that sauce? Or it could be a glaze, for example, on a donut or something like that. So it makes the bond. We've turned the graph upside down. So we actually make the bond in the negative, and then we come up to look at how adhesive. So this is the probe moving away, how adhesive it is, that main adhesion point, and then the work of adhesion. Why isn't it playing? So oh, it stopped playing. But when it's removing and you've got the what we call the legs, this is that would be the work of adhesion. And then the complete 0 point would be the debond point. So again, you can see one graph, we're actually looking at 3 different areas now, or 3 different points of interest and numerical data that we can remove from there. Lots of different examples here, whether you're looking at dough stickiness, and in fact this, again, what you can see here is that this falls under a number of different areas, because we're actually shearing the product. We're shearing the dough sample in here with a blade, but when we do that shear, we're looking at the stickiness of the blade on the dough as well. But we could do multiple passes on products, pastas, dough stickiness, confectionery type products as well. We can look at lots of different areas of adhesion. We call that, all those stickiness readings are under the adhesion heading. Our instrument gets totally connected. It's one of some of the unique things that the texture analyzer can offer you, that no other manufacturer can. So getting the most out of your texture analyzer are unique products like the key for dough extensibility. This was designed with the Stable Microsystems instrument originally, but also we can offer products like what we call a dynamic integrated balance. So as well as reading the force time graph, we can add a third axis, and we can read if you had an actuation force, or you had trying to think of an easy product, a squeezy cheese or something, where you actuated and product fell from the vessel, and you wanted to weigh the product that was actuated. That's all possible with the texture analyzer as well as controlling and reading temperature as well. We can read temperature and we can control temperature using Peltier cabinets and thermal cabinets. The thermal cabinet gives you capability of running at -40 up to 180 degrees to test your product as well. But again, some of the unique things available with the texture analyzer, we offer what we call a powder flow instrument to look at how powders perform under certain stresses or certain tests. So we can look at how a powder cakes, the cohesiveness of a powder, and also a speed flow dependency. So if you're moving powders around a factory potentially, or if you're looking at how powders bulk when they're delivered in large quantity as well. We also have a system called an ALICE. So if you want to look at multiple samples, one straight after the other, ALICE stands for Automated Linear Indexing System. The axis moves left to right, so we can look at individual samples, one straight after the other, without having to have any further interaction with the instrument. Further to that, 2 very unique features is the video synchronization and acoustic envelope. Our instrument is able to have a video that can simultaneously record video at high speed at up to 50 frames per second, and look at the graph at the same time. And I have an example of that after this slide for you. The advantage here is that if you have something with very limited samples, you can record it and visually see again and again and again how that product performed under the test that you've just created. I like it in academia, so that if you want to show somebody how something performs, rather than having to run lots of samples, or on a day like today, where you have multiple attendees, using the video synchronization system can work really well as well. And then we have the acoustic envelope detector. I'm going to tell everybody a very little secret here. It is being further developed at the moment. So you will be the first in the world to know that we are further developing our acoustic envelope, so that you can repeat the sound. We will actually record the sound and you'll be able to repeat the sound, and it will be synchronized to the graph again, just like the video sync as well, which we hope to be able to release at the end of the year for you. But ultimately, what the acoustic envelope does right now is it can record the sound of your product. So if you have a product that has a very unique sound, like potato chip crisps, for example, you can record those sounds and analyze the graph and the sound together. So you can actually see the sound wave as a third axis in our software. I think a very nice example that we have that can be shown is, for example, a carrot. When you take a carrot, if you snap the carrot, it has a very distinct snapping sound. And that's possible in a 3-point bend rig, as an example there. Listening to the sound of the carrot snap is possible. To give you an example of how the video sync works with the actual graph as well. So this is our fizzy drink can. You can see how the graph is synchronized. You can see the point working together with the video. Now I can't with this particular one because it's in a presentation, but in the software you can step frame by frame through the video, and which moves the graph step by step through the data points of the graph as well. So if there's very specific areas that you want to understand, I'm going to try and pause this at the right point, but I'll see if I can make it work. Just missed it. Can I? No, I'm going to just try and see if I can. So at this point, I can't show you. I'm really sorry. I wish I could show you. At this point, when this is in the exponent software, in the stable microsystem software, when this point breaks here and we get very small, tiny droplets of liquid being forced from the break point in the can, we can actually identify that exact point on the graph compared to the video. So it's a very unique feature. The fact that it's actually synchronized is very unique as well. Other companies have tried to do this, but they don't do it as well as stable microsystems. So a very quick summary. Texture analysis is a highly adaptable way to gain an objective assessment of the characteristics of materials. As we said at the very beginning of the presentation, it doesn't have a good or a bad day. The instrument just tests to the settings that you ask it to and gives you a very visual with the graphs representation, but also once you have that graph, you can analyze and have numerical data to be able to compare to products. We think it's a combination of excellent hardware. Our instrument, as we said, has been around since 1983 and has gone through a number of developments. And right now we have the very latest Connect series. Our software is unique. And it is developed and written in-house. We don't go externally. We have 4 very good IT people that write our software for us. And there is a huge amount of analysis available within the software. We have a large range of fixtures, over 200 probes and fixtures available to work with the instrument. So lots of different applications. We think we have the very best application support as well. We have over 400 sample applications in the software. But here in the office in stable microsystems, we've developed and worked with many different areas of testing, with industry, with academia. So we have very good understanding of texture analysis. That is our core business. That's what we do. And of course, we've been around for more than, it says 20 years, but actually it's well over 30 years now. And we have the great honor to be able to work with some of the very best distributors globally as well. I'm really, really happy to say that Mr. Henge and Rabina have been with us for many, many years. I don't know how long it's been, but it's been for a very long time, 20 years plus, I suspect. And then we have worked very closely with them over that period of time. One instrument, endless testing possibilities. Thank you very much. My presentation is now finished. I believe we go to a question and answer session, which I'll be very happy to answer as much as I can.
Thank you. Thank you very much, Paul. It was very interesting, very informative, and also comprehensive review regarding the texture analysis principle based on the experience that has been specifically at the stable microsystem. I just want to add you some a bit more information regarding this seminar, actually, in this webinar. Actually, we have graduate courses of food analysis. It was last semester, and one of the topic of that course is also regarding the texture analysis. And some of these participants is actually within the class. So this is part of the, they have been graded, so they don't have to worry about their grade anymore. So with that, I would like to invite them to, maybe if they have a question, but not only the student in the class, but also any other participant. If you have a question, I would like to ask to Mr. Paul Brown. Please identify yourself, and then I will try to call you. If you can raise your hand, for example. Is S.Pi still here? Is S.Pi still here? No one. Okay.
Yeah, Pak.
Oh, okay. Okay. Yes. So especially for PICO has a very deep experience in using this instrument. And also I saw also some of the researcher from Pak Dodi, ya. Pak Dodi ada kalau nggak salah tadi. Pak Dodi Handoko, ya. From Rice Research Institute. So if you have any question, please raise your hand. And okay, I have one here. Marcella. Yeah. Okay, please, Marcella, you can open your video so that we can see you.
I'm sorry, like right now I'm the outside of outdoor.
Okay.
I can come. I have a question.
Please. Yes, please.
Okay, so when doing an analysis with a texture analyzer, how do we determine to use the right trigger and probe so that the reading curve accurately describes the quality of the product? Because there may be materials whose characteristic can be measured by several analyzers. How we can choose the right probe to the material. Thank you.
Okay, you may respond directly, Paul, please.
Okay, thank you. It's not an easy question to answer because there is the advantage, the great thing about texture analysis is there is no absolute standard to say you have to test a particular way. That's the advantage. So it gives you very great flexibility. The disadvantage is then, as you say, is how do you find out which probe to use and which trigger force and how to test. So for me, the best way, there isn't one just way. I would look at potentially looking at something like Google Scholar and use Google Scholar to look at what other people have tested and how they have tested product previously. So this will give you a good indication of how other people have tested a very specific product and the test settings. There may also be some standards, so whether it be an ISO or an AACC or a DIN standard. So I look at those. As I've previously said, there is within Exponent software, there are over 400 application studies, so sample applications. So I would potentially also look at those to understand whether we have in the past done something. And then you need to look at those very objectively, because it may not be that we've looked at your very specific product, but it may be that we have looked at something very similar. So look at something very similar and how that has worked as well. And then really the community of texture analysis, whether you use something like LinkedIn, or whether you contact Stable Microsystems directly, or whether you contact Mr. Henge directly, we can help guide you through those as well. That's how there isn't a standard answer, I'm afraid, to say you have to go and look for this. It is more a case of reviewing how best to make that test in externals. So if somebody has done it with 3-point bend rig before and got very good results, then maybe you look at 3-point bend rig. If somebody has punctured it with a 6mm probe, you could look at a 6mm, but potentially you might say, okay, well, my consistency is slightly different, so I want to use a larger probe, a 10mm, or I want to use something smaller. I want to use a 4mm or a 2mm. So there is no standard. You have to do it a particular way. You have that flexibility to be able to research how it's been previously, potentially the product's been previously tested. If you can't find any research, then I would say the best people to ask is either going to be Robina or Stable Microsystems, and we can help you. We can try and guide you to what we would expect to test, or how we would set it up to test it. Does that? It's not a direct yes or no answer, and it's not a direct here is the answer. But I hope that helps a little bit.
Yes. Thank you. I would like, if I may add on this, is that an instrument basically is trying to mimic how people or individual trying to characterize the texture of the food itself. So first thing I think very important for you or for us, if we would like to use or to select instrument, is trying to understand how we as a people, when consuming or chewing or evaluating the characteristic of texture of the food that we will be analyzing using instrument, that's very important understanding first. And then after that, trying to select what the best instrument we will mimic the way we perceive the characterization that we usually do. I think that's a little guidance on that. And then after that, you may, as Paul mentioned, trying to check what other people, if there is other people that have been doing the same thing, it can be used as a reference as well. Thank you. I think that was.
I would agree with that. And in fact, what I would just add very quickly is that if I am asked to, if somebody brings me a sample or a product and asks me to test, the first question I ask before anything else is, what do you want to know about the product? Because that will guide us towards how we test it as well. So thinking about taking that product, okay, what is it I need to understand about this product, will guide you in the direction of whether it's a compression, penetration, 3-point bend, back extrusion, etc. That will help immensely.
Yes. Thank you. Hope that answered the question, at least give you some insight for that. And I see Safira now. Safira Karlin, please. Can you turn your video on?
Yeah, I can put my video on also. Hello,
Okay,
thank you, Paul, for the presentation. It is very, how we say it, informative for us. I mean, especially for me. I have a small question related to the part on the tension or the extension, where it can measure on the stretch and the elongation. Can this part, one also used to measure how the meat fiber breaks? It's not the cutting part, it's more to the fibers. Why I ask this question is basically that when we are developing a meat analog product, so far that we already know in the market that they have this, how we say it, like the minced meat. So it's like the reform one. But then what we are trying to do is if we want to develop something that really mimics the fibers of the meat. So then you get that kind of sensation. So now we're just looking which kind of tool that we need to use to be able to create the meat analog that has a similar fibers like meat, where you can have that sensation. I hope you got what I meant.
Okay, so the problem will be with particularly with tensile grips is once you grip the sample, I think I mentioned earlier, you create stress points at the grip point. So when you pull it apart, it separates at the grip part, which can cause a problem. So depending on the sample itself, potentially I would look at the best way to do that. I would suggest, again, just depends on the sample, would be what we call a biaxial tensile test. So we lay the sample flat and hold it in place, and we push from the top through the product. So we're looking at the extensibility of the product. It's a biaxial. So if we have the product is flat and we have a hole, so that the product completely covers the hole, and we push a round probe or a ball probe through the product and look at the tensile strength that way, rather than the traditional pulling it apart. We look at it on a biaxial basis. I mentioned it earlier, like I said about flatbreads. It would be exactly the same way as testing in a flatbed basis. That would be my suggestion. Whether the sample is possible to do that, we would have to review. The only alternative is that somehow, and this is the difficulty, is that you I know of a customer that has taken a sample that is not possible to grip because it fails. What they have done is they've frozen the ends of the sample. So they use dry ice. So they put the sample, very small part of the sample, into dry ice, and they clamp that part of the sample because it creates a clamp point.
Yeah.
They can grip those points because they're solid, and then they can make a tensile test. But that's quite an extreme way of being able to achieve it.
Yeah, because also with the dry ice or the liquid nitrogen, also it kind of, how you say it, it's kind of hazard in the lab. I mean, in the normal
for
practice.
sure. Yeah, for sure.
Yeah.
So that's not it's an extreme way of doing it. I would, depending on the sample and the size of the sample, I would potentially look at biaxial tensile test. So it's called a HDP TPB. It's called a tortilla pastry burst rig.
Okay.
That's if you have the software. If you look in the educational zone under fixtures and look at HDP TPB, then that will give you an example of how it works. It's going to talk about bread, but don't worry about looking at bread. It potentially would do it with a meat replacement based product as well.
Yeah, okay, because I think what you're trying to say also in the bread by means that you're talking about the fiber that the gluten made, right?
Yes.
Okay, clear. I can see the correlation. Yeah, thank you so much.
Okay,
no problem.
Thank you. So again, this is the classic example as how to choose or to select texture analyzer for specific purposes. Okay, I saw some. Hello. Please turn off your mic, please. Yeah. Thank you. Okay. I saw some has a question in the chat, but I would like to invite them to read their question by themselves. Indah Kurniasari here. Indah? Hello? No? Okay, then Ifadia Fatin?
Yes, sir.
Yes, please.
Okay, I'm sorry I cannot turn on my camera right now. So, good afternoon, Sir Paul. Thank you for your delighting presentation. I would like, so now I'm a student of Food Science Department of Kasetsart University, and now I'm working on mung bean pasta. And now I'm still figured out which kind of texture analysis that applicable to measure in my sample. But the problem is my sample, what is it? It's really weak. So maybe in your opinion, you can give me some suggestions based on your experience or your study, which kind of texture analysis that I can use or I can do in my mung bean pasta, which have a weak, like it's kind of easy to broken texture.
Okay, so first of all, what property do you want to know about the product?
So I want to. I want
is it the firmness.
Yeah, the firmness, because at first I want to test the tensile of the product, but it cannot be tested because the weak texture of the product.
Okay, and is it a spaghetti-like? So it's a thin, round, like noodle type
Yes,
product?
yes. It's around 2.8 millimeters.
The standard test that you would probably use is something like the there's an AACC standard.
Yes.
That's the direction I would go in. Now you have the AACC standard has two different types of standard now for pasta and noodle testing. And that it changes the blade, the angle of the blade, and I can't remember off the top of my head, but there are two different angles of blade to test pasta. And I would probably use that test because the blade comes down very slowly towards the pasta to make the test. But also you can use multiple strands of the pasta as well, or the pasta. So I would use you decide how many strands you would want to use, and then the more strands you use, of course, the more the increase in force capability. So if they are very soft, I would use multiple strands, obviously, but you need to lay them individually. So you don't want to stack them; they need to be laid individually. But what will happen is you make a height calibration of the probe, and then we use I believe it's a button trigger, and you move down, pushing into the pasta to a certain. So an example would be you start from a 3 millimeter distance, and you go to let's say 2.9 millimeter distance. So you start from 3, it moves down 2.9 millimeters, so very, very close to the base, and then back up. And that should give you a good reading of the pasta. And I would suggest using as small a load cell as possible, 5 kilo minimum. I wouldn't use anything bigger than 5 kilos. If you have a 500 gram load cell available, maybe use a 500 gram load cell.
Okay, thank you very much for your answer. Can I ask one other?
Yeah, please, yeah.
Okay, it's about, I still wonder, what is the crucial things that we need to concern about when we're doing the texture analysis?
The crucial things, well, the things to consider when making texture analysis, first of all, is sample preparation. And sample preparation is 90% of your testing is going to be sample prep, because the instrument cannot tell you or cannot decide for you if the sample is ready or it's not, or what temperature it is, etc. The instrument will just make the test. So you need to make sure that your sample is the same temperature. So for example, with your mung bean pasta, you either need to cook it and immediately test it so that it is the same temperature, or I would suggest highly that you cook it and then you cool it so that it's either at room temperature, or you take it out of water or the cooling agent you're using which is at a set temperature. Because temperature, particularly for pasta, is going to be very key to your testing. So that's the thing I think you need to consider more than anything else is your sample preparation.
Okay, sir. It's really, thank you. Thank you very much.
My pleasure.
Okay, thank you. Thank you for the question and answer. Now I would like to invite LB Hisma. LB, are you there?
Yes.
Yeah, please.
Hello.
Hello.
Yes.
We
Go ahead.
we use texture analyzer from stable microsystem model TX.
Can you identify yourself?
Oh, sorry. My name is LB from Unpad. Okay. We use texture analyzer from model TXT Express and Hedge. There's a case when the sample too rigid or too hard. There's a show overloaded.
Okay.
Which one best for make the test doable? Did we must reduce the test distance or make the sample thinner?
The choice is yours. There is, if you can make the sample thinner, if that's a possible capability, then yes, you can do that. What test are you using? Are you shearing it or are you making a penetration?
Penetration.
Okay, so what size of probe are you using?
P6, the 6 millimeter.
P6. Okay, so you can do one of two things. Assuming you're using a 10 kilogram load cell, which is the maximum you can use in an express instrument, express enhanced, you could you can either make the sample smaller, or in fact, so thinner, so not so thick, or reduce the probe. So going from a P6 to a P2, for example, the P2 will require less force. So basic physics, so which I'm sure you're aware of, but the smaller the probe, the less force is required to make penetration. So reducing it from a P6 to a P4 would make a small reduction. Maybe reducing it to a P2 would enable you to potentially make that full penetration. Or if you because what happens is I don't know how you sample. Again, sample preparation is key to all texture analysis. So if you manufacture a product in a particular size and you want to test it in that particular size, then we have to get a way around it. If you can manufacture your product smaller or thinner, then that would be ideal. That would help. Potentially, I would also look to reduce the size of the probe, potentially.
Sorry, there's noise before. So if what happen if we reduce the test distance? There's a setting where we can reduce the distance test, right?
Yes.
If we do that, is this still correct test or okay?
It should be the correct, yeah. And you can reduce the size of the probe and it will still be the correct test, as long as the only thing you can't do is if you make any changes either to the physicality of your sample or the probe size, the problem you have is that you can't then use that analysis to compare against old analysis of the larger sizes, because it's not comparable, because the data will be different. You can still use the test settings, exactly the same test settings in the instrument, but if you change the size of the probe or change the physicalities of the sample, then it becomes very difficult to compare to the two tests or two graphs. So that needs to be a consideration for you as well.
Okay, thank you.
Okay, no problem.
Thank you very much. Okay. Next, I would like to invite Praboyo. Is Praboyo there? Praboyo Arbin Islamawan.
Yes. Thank you for this. Actually, question from YouTube. Ika Nuriana Fauzia. the question is how to test the strength of the product against shock during distribution. For example, for wafer product in can.
Whoa.
Hmm.
Okay, sometimes we get a type of test that potentially we can't really recreate it within the texture analyzer. So we can't recreate shock within the texture analyzer. So I can't make a shock. The only potential thing you could do in what you could test is in its vessel. I'm trying to think now. Shock in a vessel. It's like a drop test. I have to say I'm not convinced we can test shock during distribution. So because if I'm correct, if I drop the product, if I drop the vessel from a height and then I open it, I have broken product inside. That's what you're trying to understand. We can't recreate that dropped capability. The only thing we could potentially do is test the fracturability of the product. And what you could do is test the fracturability of the product in a stack. So if you take 4 or 5 wafers and make a compression, is look at how much force is required to break the stack or break individual samples in the stack. So it's going to be quite a visual thing as well as quite a, so using the force and looking at how much force is required to do that. And then try to correlate that against gravity and shock resistance. It's not an easy test for the texture analyzer. I'm not convinced that there'll be, potentially there's a workaround, but there isn't a test that I can say, try this test and it will work for you, I'm afraid, because we don't do shock as such.
Yes.
So not often we have to say, sorry, we can't do that, but I think with this one, maybe it's we can't do that one.
Yeah, I think there's 2 different tests. You know, what you can do probably is to try to make a correlation between the texture property analyzed by the instrument that has been described with, you know, drop test or something like that, but not directly. I agree with that. Any more questions? I still have around 5 minutes. No? Indah Kurniasari, please. Yeah.
Thank you, sir. My name is Indah Kurniasari from Agency for the Assessment and Application of Technology. Mr. Paul, is it true that when running TPA, texture profile analysis, the samples must remain at heavy-duty platform after the first compression? I often find that my samples sticking to the probe. Is there any tips to keep the sample stays on heavy-duty platform?
Yeah, it's not an easy one. We see this quite a lot. We have developed a new product called a universal sample clamp, which does mean that you remove your HDP platform, but that's not a problem. And it's a plate that sits over the sample and then can hold the sample in place when you do that type of test, when you do a compression and then come back up. It's not easy, I'm afraid, depending on the sample. Not ideal, but you would try and hold the sample in place, physically hold it with your hands, not ideal. Yeah. I have seen a customer that actually got a type of rubber or elastic and placed it underneath the instrument, like an elastic band. So a band that went underneath the instrument and then over the top of the HDP 90 as well. And then they made it so it's not very tight, but then they were able to lift it enough to put the sample underneath from 2 sides. The compression was made, but it had enough capability of holding the sample in place. I'm afraid there isn't a standard. There isn't a very, I don't have a magic way of being able to say, do this and it will stop that happening. Because your product has a tack or an adhesion or a stickiness to it, and probably because it's quite light as well, potentially, when it lifts, it will lift the product potentially as well. So you have to be, I would say, be creative. Try and look at a method, whether it be over the whole instrument or just underneath the HDP plate with a bit of string or a little bit of rubber, so that it can be sort of hooked over the top to try and hold the sample in place without changing the sample or creating any disturbance on the sample itself.
Yeah. Okay.
I'm really sorry, I don't have a magic do this and it will stop that from happening. Ultimately, because what's happening is when the probe comes down, when it's making that first compression, it's creating a bond between the probe and the sample. And then when it comes up, the adhesion of that bond is greater than the sample weight. So it's lifting the sample.
Okay. Okay, Mr. Paul.
Okay.
Thank you.
So, sorry, I don't have a really easy answer for you, but that's what I would do. I get creative, try and find maybe a piece of string or an elastic, some sort of elastic or rubber that you can put around the HDP 90 and the sample that would hold it in place for you.
Okay.
Paul.
Thank you.
Thank you, Indah. Paul, you mentioned before in your presentation that not all product can be analyzed using TPA. Is this one of those things?
It's always difficult because TPA is a very good test, and again, this is where the question of what is it you want to know about the product will determine whether TPA is the right test or whether an individual product is an individual test is better to understand your product. I wouldn't say it's one of those areas where you wouldn't use it, but I would question, do you require the second compression? Is that something that's required? Or are you, if you're just looking for the firmness of the product, and maybe the stickiness, or if you're just looking for the firmness, or if you're doing a penetration, you're looking at how firm that product is and the work of penetration or the work of compression, maybe you don't need to do the second compression. So again, my question will be, what do you want to understand about the product? And that will guide us towards, well, TPA, yes, it works for you, or actually no, TPA, you don't need to do TPA, just do one test.
Thank you. Yes. Last question here from Ning. After this, I have to close the question and answer session. Please, Ning, can you make your camera on? Ning, are you there?
Yes, sir. Yes, sir. I want to ask about testing the hardness of the cheese. We have some sample from the quite hard cheese and until really soft. Yeah, really soft. And I want to measure about the hardness. How do we know if the result of the texture analyzer is not reliable enough to measure the soft, because it's really soft, almost liquid, something like that. Thank you.
Okay, if it's a liquid, so if it's like a mozzarella, when a mozzarella is heated, it becomes very solidified. We have a test for that. We call it a cheese extensibility test. So yes, it's very reliable for sure. So I would potentially look at something like a cheese extensibility test if it's a very runny cheese. If it's heated and becomes a liquid, cheese extensibility. There's a very specific test for that. Of course, if it's liquid, you can't test the hardness of it because it's no longer a firm product. With regards to the reliability of the instrument, I'm very confident about the instrument, and more than 10,000 people globally are more confident about the instrument. But what you can do for your confidence, you can do a force check. So you are in the software, there is a check force capability under calibration. So you can place a known weight onto the platform or hang from the load cell, and it will read that data for you, just like you do with a balance, because ultimately the texture analyzer is a very expensive balance. You can put a known weight, so a qualified weight, and you can test to make sure the instrument is working properly. So that's how I would quantify or qualify my instrument. And then if, depending on the cheese, I would look, again, depending on what type of cheese, if it's a hard cheese, obviously a compression test or a penetration test is best for hard cheese. For soft runny cheese, if a cheese is heated and becomes a liquid form, then the cheese extensibility, potentially I would look at as a test to perform.
So you mean the device can detect, is it can be measured using hardness test or not, because it is too liquid, something like that, isn't it?
But again, if it's liquid, I suspect that if a cheese is a very soft cheese, so it's it's not going to be completely liquefied, there will be some sort of viscous about it. You could use, if it's, okay, so when the cheese is in that state, when it's in that liquid state, is it always like that, or is it heated, or is it always like that in that process?
It is always like that, because some process we found quite hard, and then second sample is not too hard, and another sample is really liquid.
If the sample is always really liquid, always, whether it's at room temperature, heated or cooled, then I would possibly look at something like back extrusion as a test, because you can look at the firmness through back extrusion, and you can look at the flow of the product through back extrusion as well, the consistency and the cohesiveness of it. So I would look at back extrusion for the liquid product, and I would look at penetration or compression for the hard product.
Okay, clear, sir. Thank you very much.
Okay.
Okay, thank you. Again, the last question is, in my view, is a good example as how for us to understand what are we really looking for in terms of the textural characteristic, and after that, the next step is trying to select the best instrument available to mimic or to trying to quantify more objectively in a proper way. And there are seven principles that has been explained to us: penetration test, and then compression test, bending, searing, cutting, and so on. That's the one that has been developed. So we need to make sure that all of those are available, and we need to make sure that when we select the type of test that we will be using is really mimicking the texture perception that usually we do when we evaluate the food texture subjectively. I think that's a very important thing. I think we have come to the end for this session. I would like to express my sincere thanks to Mr. Paul Brown for his time and also his explanation, for his sharing regarding the texture analysis principle, and also thanks to Pak Hengki for providing this opportunity. Pak Hengki from Robina. Thanks again, Pak Hengki. So maybe next time when we have another courses. Maybe I can invite Pak Hengki or maybe Paul or maybe somebody else to share their expertise to the class. Okay. And thanks also to Formasip, yeah. And thanks also to PICO's lab. And with that, again, thank you very much to all of you. Hopefully you learned something new, something valuable this time. And I give the time back to the panitia, Nurafi. Yeah, please. Thank you very much.
Okay, thank you very much. Thank you very much to Honorable Mr. Paul and Honorable Professor Purwiyatno. I'm sorry.
Can I speak?
Yes, please.
Before
I'm sorry. I'm sorry. Yes, please.
Just to show, thank you for the IPB arranged for this seminar, and also Pak Pur and Pak Eko also as well participants for this seminar. I would like to inform all of you, if you would like to receive something like a monthly user news as a stable microsystems now give free of charge. Actually, the scientific or globally news about how to use the textual analysis in the field globally. So maybe if you need us to send you, please inform us. Just Pak Pur also inform for the next time seminar. Maybe you can we can arrange for that. It's no problem. Maybe for specific or how to make the right method and preparation for the right for the certain product or sample. That is very important, certainly for the particularly, I mean, for the academy, because this is a very limited sample. So the right preparations and also for the right method and choosing the right probe or attachment, it is very important because the sample is very limited. That is the maybe for the next seminar. Okay, thank you.
Thank you, Pak Hengki, and thank you, Paul, again.
Thank you very much. Thank you for your time.
Thank you. Thank you very much for Honorable Mr. Paul, Honorable Professor Purwiyatno, and also Mr. Hengki. And we can give applause for both of them. Now it's time to announce the door prize for the best 3 questions, and this is done by the committee. The selection is done by the committee, so I will tell you. So for the first door prize is given to Eli Hisma, and then the second door prize is given to Indah Kurniasari, and then the third door prize is given to Ika Nuriana Fauzia. Congratulations for all of the participants that get the door prize from us, and then the committee will contact you later. And now it's time to certificate handover session. And then for the first certificate is given to our moderator today, Honorable Professor Purwiyatno. Thank you very much, professors. This is the certificate for you. And then the second certificate is given to our main speaker today, which is Honorable Mr. Paul Brown. So this is the certificate for you. Yeah, thank you very much also, Mr. Paul.
Thank you very much.
Well, ladies and gentlemen, now we come to the end of international webinar. Thank you to our speaker today and also our moderator. And also thank you for all of participants for joining us today. I'm Nurafi Suhaima, representing all of the committee today. Would like to give you our highest appreciation for your support in this event. And we do apologize for all of our mistakes in presenting this event. Thank you and have a great rest of your day. Stay healthy. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh. Terima kasih.
Terima
Sehat-sehat
kasih.
selalu
Thank you,
semuanya.
Paul. Thank you.
Thank you. Cheer now, everybody. Bye bye.
Thank you. Bye-bye.